Hi everyone, I'm Jonathan Frost from the Azure Postgres team at Microsoft. If you've ever been told to migrate a Java application from Oracle to Postgres, you know it's never as easy as just changing the JDBC URL. You run into SQL dialect issues, ORM mappings that break, packages that don't exist anymore, and a lot of subtle things that don't fail until runtime. What I want to show you today is how we take that experience and turn it into a guided, repeatable workflow directly inside VS Code using our Postgres extension and GitHub Copilot. For our agenda today, I'll start with a quick overview of the VS Code extension for Postgres. Then we'll walk through the architecture of the application conversion tooling. After that, I'll show a demo of the AI-driven code conversion across a Java codebase. And then finally, we'll wrap up by providing some links on where you can try this yourself. Everything that you're about to see is centered around our Postgres extension for VS Code. At a high level, this is a full Postgres development environment built directly into VS Code. It allows you to connect to Postgres databases, as well as providing a full object explorer, visualized schema, and many additional features. But where this really gets interesting and relevant to this talk is the AI augmented tooling that we have for migration, including integration with GitHub Copilot. This extension brings database context directly into Copilot, so it understands your schema, your data, and your codebase. So instead of treating your database and your application as separate worlds, this brings them together into a single AI-assisted development experience. And that's exactly what we're going to illustrate on as we move on to the migration architecture. Let's start with a high-level architecture for schema conversion. In the center and right, you have your Oracle database as the migration source. In VS Code, the extension connects to Oracle, extracts the schema, and begins conversion. At the same time, it connects to a target Postgres database. And this is important. It's aware of the actual target database, including version, extensions, and capabilities. The output of this phase is not just converted DDL, but it generates what we call coding notes. These become critical in the next step, which is application conversion. So now that we move on to application conversion, for the purpose of this talk, we are focusing on Java code bases, but additional languages are also supported. Please see the documentation provided at the end for full details. Back to the architecture. First off, your Java code source gets pulled into a migration project inside VS Code. From there, the migration tooling together with GitHub Copilot Agent Mode takes over. It generates a structured to-do list and then executes that plan step by step across your codebase. At the same time, it's connected to your Postgres database. So when it updates an ORM mapping, embedded SQL, or function signatures, it's not theoretical, it's validating against the real database schema. Let's go one level deeper into what the agent is actually doing. At the center is the GitHub Copilot Agent Mode. It's orchestrating a set of specialized tools, what we call MCP tools, designed for Postgres and application conversion. These tools allow the agent to query the database, inspect schema objects, and validate function signatures. Another key input here is the coding notes from schema conversion. These capture things like data type mappings, renamed objects, and changes in the function signatures. So instead of reviewing the codebase in isolation, the agent has the full understanding of how the database changed and applies that across the application codebase. Additionally, if you're also using the GitHub Copilot App Modernization extension, this adds even more capabilities specifically for Java codebases, such as performing test compilations of the Java code. The result is a converted application code ready to talk to Postgres. Now, let's see this in action. I'm going to demo the application migration process to convert a Java application from using Oracle instead to use Postgres. We begin in our migration project. We've already completed the schema migration, so the Postgres database and coding notes are in place. Before we jump into the application migration process, let's take a quick look at our migrated tables and the application. We can get an overview of the tables migrated to Postgres using the Visualize Schema feature. Let's do that now. Within this feature, you can see the tables and the relationships that the app is relying on. Now, let's take a look at the Java application in its original state, where it currently is talking to Oracle. Let's kick it off from the command line. You can see it has a basic product listings page and a product detail page, all being fed by the Oracle database. This app is written in Java 21 with Spring Boot, Hibernate, and Caffeine on the back end and Timeleaf on the front end. I've also ran a script to copy over the small sample data from the Oracle database tables to the Postgres tables. Now back at the migration project, let's trigger the application conversion. First, we need to supply the parameters for the migration, including the codebase folder and the Postgres database containing the migrated schema for context. When I start this process, Copilot generates a composite prompt referencing our custom tools. As the process runs, it identifies Oracle-specific artifacts, connection strings, SQL syntax, store procedure calls, and begins transforming them. I am going to switch over to a completed run of the exact codebase and database, so we don't have to wait for the whole process to complete. Here, in the completed flow, we can see it was checking against the Postgres database schema to make sure the changes are valid. You can see that here. Further, when Copilot updates an Oracle package function call, it aligns the parameters with the actual converted Postgres function signature. You can see that happens here. Additionally, you can see here Copilot is updating embedded SQL directly in the .java file. Lastly, we can see the conversion completed and the test compilation was successful. So now, let's dive a little deeper into some of those code changes. First, on the employee service.java file, you can see the tooling updated the imports at the top. Then, in the prepare call lines, it updated the Oracle package syntax to now reflect the Postgres function syntax. Lastly, in this file, you can see the data types were updated, such as timestamp being used to replace date. Now let's have a look at the legacy pricing service.java file. Here, there was some embedded SQL, and the tooling was able to update this to align with the Postgres SQL standards. Now that we have reviewed the code changes, let's now perform a test run of the Postgres-enabled Java application. Since all the code is now updated, all we need to do is update the application.properties file to point to our Postgres server URL in another environmental variable. Okay, that is now done. Let's fire off a test run. Now that that is running, let's hit the same localhost port. Okay, here we can see our application is running, and now all the data is coming from Postgres. The product listing page looks good, and the product details page also looks pretty good. As we wrap up the demo, there are a few additional features worth highlighting. The first is the detailed migration report, which shows a breakdown of the before and after folder structure of the application code, and including all the files that were modified, along with some details around what was modified in those files. The second feature is the side-by-side file diff capability to compare the original codebase from the converted codebase, side-by-side built into VS Code. So, stepping back, what does this give you? First, you can migrate ORM mappings, embedded SQL, and store procedure calls in a single guided workflow. Second, the live Postgres connection ensures that changes automatically match your real database schema. Third, the agent generates and executes a structured plan, not a single prompt, but a multi-step process. And lastly, everything is captured in a report, and you can review the code changes, the side-by-side file diffs. If you want to try this yourself, here are a few resources. You can install the Postgres extension directly from the VS Code Marketplace. There's a full set of migration documentation and quick start guides available. And the tooling is actively evolving, so this is a great time to experiment and provide feedback. Thanks for watching. I'm Jonathan Frost from Microsoft, and I hope this gives you a clear path for migrating Java applications from Oracle to Postgres.